In this video, we are looking to evaluate trig functions that aren't on the unit circle. We're given a point, negative 513, negative 1213, and it's on the terminal side of an angle. It's in standard position. We are going to be looking to find all the 6 remaining trig functions. So first, we're actually going to make a very rough sketch of this. Our terminal side, it will be in quadrant 3. Here's our angle. Since this coordinate here is negative 5 over 13 and negative 12 over 13. When we have a point like so, we know that the x and y values associated with them give us a direction, horizontal and vertical. So we can, from here, draw in our reference triangle and label this side as negative 5 over 13 and this vertical side, or y, negative 12 over 13. In order to evaluate our 6 trig functions, we do need to know what this r value is. And we know that on our unit circle, x squared plus y squared is equal to r squared, our Pythagorean theorem. So if we square negative 5 over 13 and we square negative 12 over 13, and that's equal to r squared, both of these squared come out to be 169 over 169, which means our r value is actually 1. This particular coordinate does lie on the unit circle, but it is not a coordinate for one of our popular angles. And we're not looking for the angle, we're just looking for our ratios. So based on this triangle, we can look at our sine ratio and determine that it will be negative 12 over 13. The cosine of our angle will be then negative 5 over 13. The tangent of our angle will be the vertical, negative 12 over 13, divided by our horizontal, which is negative 5 over 13. When we reduce this fraction, keep change flip, we end up with the value of 12 over 5 positive. To evaluate our reciprocal functions of cosecant theta, we will just take the reciprocal of our sine, which is negative 13 over 12. The reciprocal of cosine is secant, which will give us negative 13 over 5. And the reciprocal for tangent, being cotangent, would then just be positive 5 over 12. Notice in our ratios, the 4 negatives for sine, cosecant, cosine, and secant, definitely for quadrant 3, and tangent and cotangent being positive for quadrant 3. All right, so let's look at a point that is definitely not on the unit circle. 4, negative 3. If we take a second and plot this, 4, negative 3 has a terminal side in quadrant 4. So here we are at 4, negative 3. When we actually look at this triangle, draw our little reference triangle here, we've gone over positive 4, down negative 3 with y. And if we do that quick Pythagorean theorem again, negative 3 squared, and you may hopefully not have to do this because this is a very popular Pythagorean triple, and 25 is r squared, so then our radius in this case ends up being 5. So now when we look to evaluate sine for this angle, again, we know opposite over hypotenuse, negative 3/5. Cosine is then 4/5, and tangent is negative 3/4. Our reciprocals, cosecant, negative 5/3. Secant, 5/4, also positive, quadrant 4, right? And cotangent is then negative 4/3. Okay. Our 6 trig functions, drawing a triangle, doing the Pythagorean theorem. As you know from the Pythagorean theorem, it's possible to get radical answers. So make sure you do rationalize if you do come across that scenario. All right, let's look at now finding an exact value given some certain information. In this problem, we want to find the exact value of the remaining functions if we're given sine is negative 5 over 13 and theta is in quadrant 3. So first, I know I have a triangle in quadrant 3, right? There's our angle. Angle is in quadrant 3. And the sine of that angle is negative 5 over 13. Well, sine we know is opposite over hypotenuse because we're not on the unit circle, so it's not just y. So we have 5 and 13, and the 5 is negative since we're in quadrant 3. How do we go about finding that other side, that value of x? A little Pythagorean theorem. Negative 5 squared plus x squared is equal to 13 squared. This also, by the way, is another Pythagorean triple. X 169 divided by, minus the 25. X squared is equal to 144, which is 12. This is another Pythagorean triple. Please be very, 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 very careful. Star this right here. You do have to pay attention. Yes, you got 12, but because you have gone in the negative direction, it will have to be negative 12. Please be very careful when you label your triangles to make sure what's negative is negative. Now from here, like before, we can just evaluate. We already know sine, so we're going to start off with cosine. Cosine is negative 5 over 13. Tangent is 5 over 12, right? Both negatives. Secant, nope, cosecant, sorry. I didn't write out sine. Cosecant is negative 13 over 5. Secant is, what did I do? No, this is negative 12. Sorry, I got carried away. I didn't write out sine. Sine theta is negative 5 over 13. Write things out. Won't have problems. Secant, then negative 13 over 12. And cotangent is 12 over 5. So very straightforward. When you do have some nice Pythagorean triples, just come up with the ratios. Be very, very careful, though, to make sure your signs are correct in going into the different quadrants. All right, let's look at another example with slightly different given information. These two examples were given a ratio, but now we are given the explanation of our quadrant slightly different. We are given that our theta is between 3 pi over 2 and 2 pi, which means that we are in quadrant 4. So again, looking at quadrant 4, we're going to have some kind of triangle in quadrant 4. Here's our angle of theta. And our ratio for sine, negative 2/3. We need to find our x value. So x squared plus negative 2 squared is equal to 3 squared. So x squared plus 4 is equal to 9. X squared is equal to 5. So in this case, here is a radical for our x that will be have to be rationalized with the rest of our functions. All right, so we have all three of our sides labeled. Let's go down our list. Sine of theta, already given, negative 2/3. Cosine of theta is now root 5 over 3. Tangent theta is then negative 2 over root 5. And that is a problem. You must rationalize. Right? You end up with a radical on the bottom. You must rationalize. How do you do that? We multiply by root 5 over root 5. And this whole answer comes out to be then negative 2 root 5 over 5. Okay. To continue on with our reciprocals, cosecant theta, negative 3 over 2. Secant theta, again, 3 over root 5, just like we did for tangent, we are going to multiply by root 5, and we get 3 root 5 over 5 for secant. For cotangent, I'm going to go back to the original ratio of tangent. I'm not going to take my simplified version and flip it, much too difficult. I'm going to go back to the original, and now just putting root 5 in the top makes this a much more friendly fraction. If you did use the other one, you'd have to rationalize again, but that is your final answer. In number 3, now we're given a cotangent ratio, but now we are told that the cosine is less than 0. Well, cosine is less than 0 in 2 possible quadrants, right? Our cosine is less than 0 in quadrant 2 and quadrant 4. This means cosine is negative. Okay, it is negative in quadrant 2 and 4. But combined with the fact that cotangent is positive 4 pi over 3, a positive cotangent and a negative cosine means that our quadrant that we're actually going to be, if we combine a positive cotangent and a negative cosine, we will be in quadrant 3. Okay, so the combination of both of those things, the overlap will be your actual quadrant. Okay, so let's draw our triangle, quadrant 3. Our reference triangle goes here. Here's our angle. Our cotangent ratio is adjacent over opposite, and we did this triangle before, and we know that this is going to be 5. We are in quadrant 3. Our cotangent ratio is positive, but being in quadrant 3, we know that both x and y need to be negative. So please, 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 please remember your signs. Not sayings, signs. Huh? All right, so let's go through our list. We have our labeled triangle. We can now find the sine of theta is negative 3/5. Cosine of theta is negative 4/5. And tangent theta is 3/4. Our cosecant theta is equal to, flip these fractions, negative 3/5. Secant theta is now negative 5/4, and cotangent theta is 4/3. And you've completed another 6 trig functions based on slightly different information. Okay, completing the last problem that we have, cosecant is 3, cotangent's less than 0. Well, let's look at this again. Cotangent being less than 0 means tangent's less than 0. So we want to know, where is tangent negative? Tangent's negative in quadrant 2 and quadrant 4. Cosecant is positive in what quadrant? Cosecant is positive when sine is positive. Where is sine positive? Sine's positive in quadrant 1 and quadrant 2. So now we have an overlap in quadrant 2. So our angle is in Q2. All right, so let's draw our triangle in quadrant 2. Here's our angle of theta. And we have cosecant is 3. That is the reciprocal to sine. This 3 is over 1, so the reciprocal of 3 is 1/3. So our vertical is 1, and our hypotenuse is 3. Doing the Pythagorean theorem, 1 squared plus x squared is equal to 3 squared. So x squared is equal to 8. And you do need to reduce in radical form as a simplified radical, and you get 2 radical 2. So now on the x axis, we have 2 radical 2 as our length, but direction is negative. Once we've established our triangle where it is, labeled sides, sine is now 1/3, right? The reciprocal of the cosecant we had. Cosine is now 2 root 2 over 3, negative, sorry. And tangent is 1 over negative 2 root 2. You do need to, as we did before, rationalize. So top and bottom will get multiplied by root 2. And that means that this total will be negative root 2 over 4. Cosecant was given, but I'll write it out again. That's now 3. Secant theta, we're going to flip this. It's going to be 3, negative 3 over 2 radical 2. Rationalize again. by multiplying top and bottom by root 2, and you end up with a value of negative 3 root 2 over 4. To finish this up, cotangent theta is, go back to the original, and it's just negative 2 root 2. Okay? You can write it over 1, but that's certainly not most simplified. That concludes this video, and you can now work on the homework.